A very warm welcome, students, in the another session of mathematics. Today I am going to discuss the various types of a quadrilateral. In the previous session we learnt about the quadrilateral. What a quadrilateral is? So we learned any plane surface bounded by four line segments is known as a quadrilateral. Now the condition given to us is when both the pairs of opposite sides are parallel. Then what type of a quadrilateral do we get? So firstly we are going to study about a parallelogram. Parallelogram is a quadrilateral with both pairs of opposite sides are parallel. We have a parallelogram PQRS. PS is parallel to QR, PQ is parallel to SR. What are the other properties of a parallelogram? Children, remember that opposite sides are parallel as well as equal. So PS is equal to QR and PQ is equal to SR. So we learn the first property that opposite sides are parallel and equal. Then we learn the second property, opposite angles of a parallelogram are equal. P and R are equal and PQ and angle Q and angle S are also equal. Then the third property says when we draw a diagonal. What a diagonal is? When we join the two opposite vertices of a quadrilateral, then the line segment obtained is known as diagonal. So a diagonal divides the parallelogram into two triangles which are congruent. That means the shape and the size of these two triangles is exactly same. And then another property we are going to learn that if we draw another diagonal, then the two diagonals intersect at any point. I named it as O. Then PO and OR are equal and OQ and OS are equal. So these are the properties of parallelogram. The first property says opposite sides are parallel and equal. Opposite angles are equal. Adjacent angles are supplementary. For that you understand this way. This is a parallelogram. I extend the sides of a parallelogram. As we know, opposite sides are parallel. Therefore, these two sides are parallel as well as these two sides are also parallel. If I consider a pair of these two sides, so what type of angle are these formed? These are the angles between the parallel lines and or on the same side of a parallel line. Therefore, these are the co-interior angles. Similarly, this pair of angle is also co-interior. And we know very well that the sum of co-interior angles or allied angles is 180 degree. Another name for co-interior angles is allied angles. If we consider these two parallel lines, these two are also forming a co-interior angle. I take it this way. Now, these two lines are also parallel. Therefore, this and this also form a co-interior angle. These two also form a co-interior angle. So, we learned that the sum of adjacent angles is 180 degree. That is supplementary. Then we learn one more property. Each diagonal bisect the parallelogram into two congruent triangles. So diagonal divides, any one diagonal divides the quadrilateral into or parallelogram into two equal triangles. That means they are equal in shape, same in shape as well as in size. Student, you have to write the properties of the various types of a quadrilateral. Firstly, I discussed parallelogram. So we'll write the definition of a parallelogram and you will draw its picture. So what you're going to do, write the definition of a parallelogram, draw its picture, write all the properties of a parallelogram. No need to write, you can just simply write the statement: opposite sides are parallel, opposite sides are equal, opposite angles are equal. No need to write these alphabets. Adjacent angles are supplementary. Okay. Similarly, here also the diagonals bisect each other. Each diagonal bisect the parallelogram or divide into two congruent triangles. Then I discuss theorem number 1. No need to write the theorem, just write the type of a quadrilateral and its properties. Theorem 1. In a parallelogram, opposite sides are equal, opposite angles are equal, each diagonal bisect the parallelogram. We need to prove it. We learned in the previous properties there that opposite sides are parallel and equal, opposite angles are equal. We need to prove for that. Let's see how we do it. Theorem 1. So I have considered triangle PQRS and I have drawn a diagonal joining Q and S. As we know, PS is parallel to QR and this is a transversal. So therefore, angle S is equal to angle Q here. As PQ is also parallel to SR and again this is a transversal, therefore angle Q, this part is equal to this part. And this line QS is common with both the triangles. So I am considering triangle PQS and QRS. Angle S is equal to angle Q. Here angle Q is equal to angle S here. And this line QS is common. Therefore, the two triangles are congruent under the condition of ASA. ASA, angle, side, angle. Okay. The moment the two triangles are congruent, we know very well, the remaining three elements will also become equal. Therefore, PS will be equal to QR and PQ will be equal to SR and angle P will become equal to angle R. So we learn when the two triangles are, the quadrilateral, in quadrilaterals the opposite angles are equal, opposite sides are also equal and diagonal bisects the parallelogram. Now we have to prove this. As we proved that these two triangles are congruent, that means this diagonal is dividing into two equal halves. That means the area of these two triangles will be equal. If the area of these two triangles is equal, that means the diagonal bisect the parallelogram. Similarly, you can join PR and you can find that again this diagonal also bisects the parallelogram into two equal halves. No need to write theorem 1 and its proof in the fair copy. Just read theorem from your textbook and go through its proof. Now we come to theorem number 2. Theorem number 2 says the diagonals of a parallelogram bisect each other. So we need to prove that OA is equal to OC and OB is equal to OD. Let's see its proof. So ABCD is a parallelogram. I have drawn the two diagonals, that is BD and AC. We have to prove that OD is equal to OB and OA is equal to OC. As the line DC is parallel to line AB, therefore alternate angles become equal. This angle is equal to, so now I consider triangle DOA and OAB. I am considering these two triangles. In triangle OAB and OCD, Angle A is equal to angle C, angle B is equal to angle D. Reason, they are alternate interior angles. And AB is equal to DC, because we know very well that opposite sides of a parallelogram are parallel and equal. And AB is equal to DC. Therefore, triangle OAB is congruent to triangle DOC under the condition of angle, side and angle. Therefore, the remaining three elements, that means the remaining three elements are OA will be equal to OC, OB will be equal to OD, and these two angles will also become equal. So, our aim was to prove that OA is equal to OC and OB is equal to OD. So, we have proved that OA is equal to OC and OB is equal to OD, as the two triangles are congruent under the condition of ASA. You can read the proof from your textbook also. Now I discuss theorem number 3. If a pair of opposite sides of a quadrilateral are equal and parallel, it is a parallelogram. Here we are given with that only one pair of opposite side of a quadrilateral is parallel and equal, then also it is a parallelogram. Student, this is very important theorem because it forms the base of many questions in the senior classes. So do remember, if we have only a pair, that means if we have only one pair of opposite sides of a quadrilateral parallel and equal, it should be parallel as well as equal, then it is a parallelogram. Let's see its proof. So here we are given with the quadrilateral ABCD, whose side AB is equal to DC and AB is parallel to DC also. If these two lines are parallel, then angle A is equal to angle C, because these are the alternate interior angles. AB is equal to DC, it's given, and this side AC is common to both the triangles. That is triangle ABC I consider and ADC I consider. I consider these two triangles. These two triangles are congruent under the condition of this is side, angle, side. In this side, angle and side. Therefore, under the condition of SAS, the two triangles are congruent. Therefore, all remaining elements will also become equal. So, what are the remaining elements? So, angle A will be equal to angle C. The moment angle A is equal to angle C, that means AD is parallel to BC. Why? Because these two are forming a pair of alternate interior angles. Okay, children? The moment the alternate interior angles become equal, AD becomes parallel to BC. So it's very sure if we have only one pair of opposite sides parallel and equal, then also the given quadrilateral is parallelogram, because when we prove this opposite pair is also equal and parallel, therefore it is a parallelogram. Now we consider another type of a quadrilateral. Now we discuss about a rectangle. Rectangle is also a parallelogram whose each angle is 90 degree. So rectangle is also a parallelogram, and what the difference between rectangle and parallelogram is, if each angle of a parallelogram measures 90 degree, then it is a rectangle. And so what are the properties of rectangle? Rectangle will possess all the properties of a parallelogram. So opposite sides are parallel and equal. As we learned that rectangle is a special parallelogram with each angle 90 degree. Therefore, each angle is 90 degree. As we learnt in the parallelogram, the diagonal bisect each other. Therefore, the diagonals of a rectangle also bisect each other. The third property, that we are going to learn here. Diagonals are equal. Children, diagonals of a parallelogram are not equal, but in rectangle diagonals are equal. Remember. Now we come to theorem number 4. The diagonals of a rectangle are equal and bisect each other. Okay, so as we proved above that the parallelograms diagonal bisect each other, the same way we can prove that the diagonals of a rectangle are also bisecting each other. Now what important here is to prove that the diagonals of a rectangle are equal, which is not in the case of a parallelogram. Let's see its proof. We are given with a rectangle PQRS. It's a rectangle, so each angle measures 90 degree. Now which two triangles I am going to consider? I consider triangle PQR and triangle QSR. I am taking these two triangles. This is the one and this is one more. In these two triangles, PQ is equal to SR because opposite sides of a rectangle is equal. Therefore, these two sides are equal. Angle Q as well as angle R both are 90 degree. And this side QR is common to both. Therefore, triangle PQR is congruent to triangle QSR under the condition of side, angle and side. The moment these two triangles are equal, the remaining elements will also become equal. So, PR will become equal to QS, and PR and QS are the two diagonals of a rectangle. Therefore, we learned that the diagonals of a rectangle are also equal. Now we learn about the third type of a parallelogram, third type of a quadrilateral, that is square. Square is a rectangle. Having all sides equal is called a square. Square is a special type of a rectangle, children. Rectangle is a special type of a parallelogram. So, square and rectangle both are a parallelogram. Rectangle is a parallelogram. Square is also a parallelogram. And square is also a rectangle. So what the difference between rectangle and a square is? There all in rectangle opposite sides are equal, but in square all the sides are equal. In rectangle each angle measure 90. Similarly in square also each angle measure 90 degree. So what a square is? Square is a special type of a rectangle whose all the sides are equal. So what are the properties of a rectangle? Square. See, a square will possess all the properties of a rectangle as well as parallelogram. So what are the properties of a rectangle and parallelogram? So what the difference between square and rectangle is? That all the sides are equal. So what the first property of a square is? That all sides are, if all the sides of a quadrilateral equal, then it is a square. Each angle is 90 degree, as we learned in rectangle also each angle is 90. We learned in a rectangle that diagonals are equal, as square is also a rectangle. Therefore, diagonals of a square are also equal. Diagonals bisect each other. So, as the diagonals of a rectangle as well as of parallelogram bisect each other, therefore the diagonals of a square also bisect each other. One special property, see what's the difference, what the specialty, extra quality the square has, that all the sides are equal. And one more property that make it specific is diagonals intersect at right angle. We know very well that diagonals of a parallelogram bisect, diagonals of a rectangle also bisect, but square's diagonal also bisect, but at an angle of 90 degree. This is the very important property of a square. Do remember. Now we learn theorem number 5. The theorem number 5 says the diagonals of a square are equal and bisect each other at right angles. We need to prove them. See, the diagonals of a square are equal as we proved in theorem number 4. Similarly, we'll prove in theorem number 5 also, and then we'll prove that they bisect each other at right angles. Let's see its proof. The first thing that we are going to prove that the diagonals of a square are equal. For that we consider triangle A, B and C, and we consider triangle B, D and C. These two triangles we consider. AB is equal to DC as the opposites, as all the sides of a square are equal. These angle B and this angle C both measure 90 degree, as each angle of a square measures 90 degree. BC is common to both, therefore the two triangles are congruent under the condition of side, angle and side. The moment these two are congruent, the remaining three elements will become equal. Therefore AC will be equal to BD. So the first part we have proved that the diagonal AC is equal to diagonal BD. Now to prove another part that diagonals bisect each other, for that I consider triangle I let the diagonal bisect each other at O. I consider for that BOC and AOB. I consider these two triangles. We consider triangle AOB and BOC. We know AB is equal to BC as the sides are equal. OC is equal to OA. The diagonals bisect each other, therefore these two are equal. And this side BO is common with both the triangles. Therefore the triangle BABO and OBC are congruent under the condition of triple S. The moment they are congruent, the remaining parts will become equal. Therefore angle this and this will become equal. Okay, and the sum of these two angles is 180 degree because it is a straight line. The sum of these two angles is 180 degree, and these two angles are equal also from CPCT. Therefore each will become 180 by 2, that becomes 90. So we learned that the diagonals of a square bisect each other at right angles. Now we study one more type of a quadrilateral. A parallelogram having all sides equal is called a rhombus. So rhombus is a parallelogram where all the sides of the parallelogram are equal. So this we learned in square also. A square is a rectangle and rectangle is a parallelogram. So again rectangle is a parallelogram with all the sides equal. So what the major difference between a rhombus and a square is? See, in square each angle measures 90 degree, but in rhombus each angle does not measure 90 degree. This is the difference between a square and a rhombus. Rhombus has all the properties of a square, but the difference is in square each angle measure 90 degree, but in rhombus it does not. So what are the properties of a rhombus? Opposite sides are parallel, as we have in all the quadrilaterals we studied till now. All sides are equal. The sides of the rhombus are equal. Diagonals bisect at 90. This is another property of a square. So these three properties are of square only. Diagonals bisect the angles of the rhombus. So we learned this also in square, that diagonals of a square also bisect at 90 degree. Here also the diagonals of a rhombus bisect at 90 degree. Now the fourth property is important. Diagonal bisect the angles of a rhombus. If we draw the diagonal, it bisects the angle, that means these two angles, this angle C is bisected into two equal halves. Similarly, angle A is bisected into two parts. If we draw the diagonal of a rhombus, it divides the angles. Okay, children? So this way we discuss the properties of a rhombus. Now we learn theorem number 6. Theorem number 6 says the diagonals of a rhombus bisect each other at right angles. So that means we have to show that OA is equal to OC and angle OB is equal to OD, and angle AOB and COB both measures 90 degree. Let's see its proof. In first part, we need to prove that the diagonals bisect each other. So for that I consider triangle OAB and triangle ODC. These two angles are alternate angles because opposite sides are parallel. Similarly, this angle will be equal to this because again these two lines are parallel, therefore alternate angles will become equal. Now AB is equal to DC. As we learnt, all the sides of a rhombus are equal. Therefore the two triangles become congruent under the condition of angle side angle. The two triangles are congruent now. Therefore the remaining elements OB will be equal to OD and OA will be equal to OC. So this way we have proved that the diagonals of a rhombus bisect each other. Now we will prove that the diagonals bisect each other at 90. For that I'll consider angle ADO and OAB. We learned just now that OD is equal to OB, AD is equal to AB as the sides of a rhombus are equal, and OA is the common side. Therefore the two triangles become congruent under the condition of triple S. If the two triangles are congruent under the condition of triple S, therefore these two angles will become equal. If these two angles are equal and they form a linear pair, therefore each will become 180 by 2, that is 90 degree. Hope you have understood the theorem number 6. See students, I have discussed all sorts of a parallelogram today and the theorems related to them. Today you are going to read all those properties as well as theorems with proof, and in your fair copy you are going to write the various types of a quadrilateral and their properties. No need to write the theorem and its proof, but you should go with that theorem and its proof from the book. Okay, so that's the end of the session. I'll discuss the remaining types of a quadrilateral in the next session. So what your homework for today is revise the properties and write it in your fair copy along with the figure. Theorems you have to read from the book and just memorize it from the book itself. Thank you children. Have a good day.